Hello. Yes. We welcome you back to this channel, PSSB, Physical Sciences. Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that consider the equation below. This is the equation. Okay. They say 4 grams of sodium chloride is mixed with 3 grams of water. And the first question says, calculate the mass of sodium hydroxide, which was formed, that is sodium hydroxide. So how do you go about this? This is what you have to know, that both the reactants are given. So there's a trouble here that we don't know which one will determine the direction of this reaction. Which one will determine when the reaction will stop. You have to know that the smaller amount, the one which is smaller in terms of moles, is the one which will determine when the reaction will stop. Once it is finished, the reaction has to stop because the other compound which is still available has nothing to react with. So such a compound which determines when the reaction stops, we call it limiting reagent. So our first job here is to determine the limiting reagent. So let us have that. Okay. Yeah, that is that. Let us do this. Determine which is smaller, the one which will get finished. So the first step is to have both our reactants. We have, it is sodium chloride and water. Our next step is to look at the ratios. It is 2 to 2. Yeah, let me put it here. These are the ratios. Next one is to have the masses. For sodium chloride, it is 4 grams, while for water it is 3. Yeah. Next is to get the number of moles of each. So this is the mass. Now we go to moles. Now number of moles are obtained by this equation. What's the equation? N is equal to mass over molar mass. So when you come here to substitute to get N, you're going to have your N as mass, which is 4, and the molar mass of sodium chloride, which we need to determine. So let us determine the molar mass of each. For sodium chloride, the molar mass is going to be sodium, which is 23, plus chlorine, which is 35.5, giving us yeah 58.5. Okay. Meanwhile, for water, yes, you find it also. It is made up of H, which is 1, but times 2, plus oxygen, which is 16, giving us 18. So back to our flow. What do we do here? So it's going to be, we are calculating number of moles, and the molar mass of sodium chloride, we have it here, which is 58.5, while this side we do the same. We calculate the number of moles. So it's going to be 3, which is the mass, divided by the molar mass, which is 18, giving us yeah, there we are. So here our number of moles is 0.034, and here our number of moles is 0.17. Next, you check the ratios. What are they? The ratios are the same. If the ratios are the same, then the number of moles are indicative of the actual number of moles reacting. And the one which is smaller is the limiting reagent. So between the two, it is this one which is smaller. So it is this one which is the limiting reagent. So it is sodium chloride which will determine when the reaction will stop. Once sodium chloride is finished, the reaction will stop. What is the importance of that? We are going to see it in the next part. Yeah, after that, now we can come and answer this question. It wants the mass of sodium hydroxide which was formed. So where do we start from? You go back to the equation. The equation is 2 sodium chloride aqueous reacting with water to give you chlorine gas, hydrogen gas, and sodium hydroxide. So at this level, we have identified that it is sodium chloride which is the limiting reagent. Next, you also identify the compound whose mass you are going to calculate. Okay, then from here you start. What's the mole ratio? The ratio is 2 to 2. But this side we determine the number of moles already. Yeah, the number of moles we determined previously is 0.034 moles. These are the number of moles of sodium chloride which reacted. But from the ratio, the 2 forms 2. And these are mole ratios. So which means that this number of moles are going to be the same number of moles which are formed of sodium hydroxide. Yes. So that is it. This is very important. So from there, what do we do? You come to this compound. What is it? Sodium hydroxide. Because it's the one you are calculating. And you list everything you know about it. First, we know the number of moles, which is 0.034 moles. What else do we know? We calculate the molar mass it's required, which is it's sodium hydroxide. Okay, what is sodium? Sodium is 23 plus 16 plus 1, giving us 40. So this is the information now we know about sodium hydroxide. Next step is to calculate the mass using the relationship which says that number of moles is equal to mass over molar mass. And what is the number of moles? It is 0.034. And what's the mass? It is what is wanted. And what's the molar mass? It is 40. From here, what do? We cross multiply. And we get our M, which is the mass, as 0.034 times 40, giving us 1.36 grams. Yes. What you have here is the mass of sodium hydroxide which was formed. Now, after getting the mass, what do? We go to question B, because question number 1 has been answered. Question B says that at the end of the reaction, 1.16 grams of sodium hydroxide was formed, and they say calculate the percentage yield. So this is what we are going to answer now. Yeah, now we come to question B, which wants percentage yield. Okay, and how do you go about that? This is what you have to know, that percentage yield is given by an expression which says actual mass yield over theoretical yield times 100. Yeah, this is the expression which we use to calculate percentage yield. Now the question is, do we know the actual yield? Yes, it's the one which is given in the statement. It is 1.16. And do we know the theoretical yield? Yes, it is 1.36 times 100. What do we get? We get 85.29%. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye-bye.